Hello, everyone. Today we're going to be covering section 7.5, common logarithms and natural logarithms. In this video, we'll go over the graphs, the interval notation of domain and range, and problem number 1 and problem number 2. If you notice the graph of 10 to the x, e to the x, and then the graph of the natural log of x and the log of x. Okay. Remember that logs and exponents undo each other. So when you have the variable in the exponent, they are inverses from the log functions. Remember the inverse? How do you find the inverse? Switch the x and y. An inverse function is reflected about the line y equals x. So if I took this graph and made a dashed line right through y equals x and folded it in half, then you would see that e to the x would lie right on top of the natural log of x, and 10 to the x would lie right on top of the log of x. Why does that work and how does that work? That's what we're going to talk about in this section 7.5. Let's think about the domain and range. If you notice, f of x equals 10 to the x, this gold one here, that's an exponential function. The domain, so driving your car across, is negative infinity to infinity. The range starts at 0, so going up the elevator, 0 to infinity. And I've put those here with the same color so you can get that matched up. Okay, if you look at the domain and range of the log of x, so this purple one here, notice the domain goes from 0 to infinity, driving your car. The range goes negative infinity to infinity. Now let's look at the blue graph, e to the x. So here's f of x equals e to the x. And once again, the domain driving your car, negative infinity to infinity. Then the range starts at 0, 0 to infinity. And you look at the red graph of the natural log of x, the domain again, 0 to infinity, and the range, so now taking the elevator, negative infinity to infinity. There are so many connections here. Remember that exponential functions and logarithmic functions undo each other. When you're solving, that's how you get x alone. You've got to use them to undo each other. They are inverse operations, which means with their graph, you can fold them about the line y equals x, and they lie right on top of each other. They're inverses. What does that mean? Switch the x and y. Notice the domain of 10 to the x is the range of log x. And the range of 10 to the x is the domain of log x. So 10 to the x and log of x are inverse functions. The same for e to the x and natural log of x. And we'll discover those definitions here in the notes. Let's look at the definition of the common log. So y equals log of x, or log base 10 of x is called the common log. What base do we use in our calculator? What base do we think in? 10 fingers, 10 toes. We think in base 10. What is our number system? All the place values? Base 10. So when we use our calculator, if I just punch log of x, that means we're using base 10. It's called the common logarithm because that's what's common to us. There are other bases and other applications. What about computers? 1010, the binary code? Computers think in base 2. All right, so the common base is common to us, base 10. Remember, when you switch forms or undo the log base 10, then the exponential form is 10 to the y equals x. So that's how you see they are inverses, just like on our graph. Now let's try a few. Evaluate without using a calculator. Okay, so how do I evaluate a logarithm? I can just change forms. How do you change forms? So I just do a little chant, silly me. I like to say all about the base, no treble. So you're talking about all about the base. and then you're dancing in a circle. So that's my memory hook. It's all about the base and you circle it up. So if y equals log base b of x, how do I change to exponential form? All about the base. So I start with the base of b, and then I'm dancing already. So I go in a circle. So b to the y equals x. So there's your circle it up. And we can go back and forth. So if I start in log form and I want to go to exponential form, so b to the y equals x. Now, if I start in exponential form, same dance, all about the base. You know that b is the base, so you'll start with log base b of x equals y. And you can switch it back. So I start with log, base b, all about the base, and then of the other side, so of x, and then equals y. Boom, I'm back to where I was before. Doesn't matter that y is on the other side. That's just the property of equality, so that's fine. All right, so hopefully that little hint will be helpful. Now let's solve. What is the log of 1? So this means log base 10 of 1 equals question mark. And I can follow this process all about the base. So 10 to the other power, which we don't know what it is, question mark, equals 1. 10 to some power equals 1. Okay, 10 to what power? Anything to the 0 power equals 1. You're right. So A is 0. Let's look at B. I know this is base 10. So log base 10. And what is 1 over 100? Could I make that a base 10? So that could be 10 to the negative 2. Remember, 100 is 10 squared. And so if that's in the denominator, I can move it to the numerator by changing the sign. Now I have log base 10 of 10 to the negative 2. Log base 10 of 10 undoes each other. Boom. And I'm left with negative 2. Let's try C. Log base 10 of 10 squared. Log base 10 of 10 will undo each other, and I'm just left with 2. What about this one? Log base 10 of 10 to the 1/4. Remember, as an exponent, the fourth root is 1/4. The log base 10 of 10 will undo each other, and you're left with 1/4. So you can just make sure you have the same base, or you can switch forms. There are a couple of different ways to figure that out. What if I switched forms? This would be log base 10 of 10 to the 1/4 equals something. So all about the base, 10 to the question mark equals 10 to the 1/4. So the question mark is 1/4. Let's try problem number 2. Evaluate using a calculator, round to 4 decimal places. So now is when you get out your calculator and you just want to make sure that you're punching it in properly. A lot of calculators have a different way to do it. So just make sure you're familiar with your calculator. Log 50. So find the log of x. And you know what's so cool? On your calculator, the log of x is usually right underneath 10 to the x because they undo each other. Okay, let's find that. And I can just punch that in. So sometimes you punch 50 and then you punch log. Sometimes you punch log and then you punch 50. So see what works for your calculator. So 1.69, that rounds up to a 10 and that rounds up to a 9. Okay, let's try 720. So now the log of 720, this will be 2.85733. So it stays the same. 8573, and the next one's a 3, so we're good. This one is log of 0.23, so 0.23. This one will be negative 0.63827. So 6383. And then the last one, the log of 1300. 3.11394. So then it stays. I hope that helped you understand a little bit more about common logs. I'll see you next time.